Okay, so today we'll be working on the Codility question, number of disk intersections from the lesson sorting. I thought this was a relatively challenging problem. The major challenge comes from understanding what the actual problem is and what it's asking for. So let me go over the question first. We draw n disks on a plane, as shown in the image over here. The disks are numbered from 0 to n minus 1. An array A of n non-negative numbers, specifying the radius of the disk, is given. The jth disk is drawn with the center at j, 0. So we're on the x-plane, and a radius of A of j. We say that jth disk and kth disk intersect if j is not equal to k, and the jth and kth elements disks have at least one common point, assuming that the disks contain their borders. The figure below shows disks drawn for n equals 6 and A as follows, and they give us the diagram. There are 11 unordered pairs of disks that intersect, namely disks 1 and 4 intersect, and both intersect with all the other disks. And disks 2 also intersects with disks 0 and 3. Write a function that, given an array A describing n disks as explained above, returns the number of unordered pairs of intersecting disks. The function should return -1 if the number of intersecting pairs exceeds 10 million. Given array A shown above, the function should return 11 as explained above. Write an efficient algorithm for the following assumptions. N is an integer between 0 and 100,000, and each element of array A is an integer within the range of 0 to 2 billion. Okay, so let's look at this question again and see what it's asking. So 1, they give us an array A. A is an array of radiuses. So every value within the array A is the radius of a circle at a point I in the array. So every index in the array is its position on the x-axis. So I is equal to center point of circle on x-axis. 2, they want us to find intersecting points. And to understand what they're asking, we actually have to understand what they mean by intersecting, right? Do they want to find out whether intersecting means where they actually intersect? Is a circle intersecting with the larger circle if it's contained within the circle and it doesn't cut through its borders? So that actually is what confused me initially, right? Because I wasn't sure what they were asking by that. So in this case, what intersecting means is when the borders either cut across the circle. So border passes into the circle, or circle is contained within the larger circle, right? So it doesn't actually have to pass through the border or intersect if it's contained within. That also means the smaller circle, the bigger circle intersects the smaller circle, right? So those are the two conditions for determining whether a circle intersects it. So this is what we want. Identify intersecting points. Don't double identify intersecting circles, because sometimes if one circle intersects a bigger circle, as we're iterating through it, we could re-identify the other circle intersecting the smaller circle, but we don't want to double count it, right? So for example, the circle which has a radius, a center point at 0, intersects the circle that has a center point at 2. But also the circle at center point 2 intersects the circle with center point 0. So we don't want to double count. Okay, so let's go through a few examples of intersecting points. So for 0, for circle 0, the circle that has a point at 0, it intersects with the circle that is at 2, as well as the circle that has a center at 4. Right? Those are the two circles it intersects with. It doesn't intersect with anything else. The circle at position 1 intersects with all the other circles. So that would be circles 0, 2, 3, 4, 5. Right? As specified below. Circle 2, they already gave that to us, intersects with points 0 and 3, right? But in our case, the way we looked at it was that, actually let's do this for now. So we're ignoring this condition currently, right? Which we won't ignore later on when we create our algorithm. So circle 3, which is at center 3, only really intersects with circle 2. Actually, that was my mistake. Circle 2 is bigger than 3 and 4, right? So it intersects them both. 3, 4. So we're only including the radiuses that are smaller. So we'll go from big to small, right? Intersects. That's what it seems like. Okay. So circle 4 intersects with all the others. So that would be 0, 1, 2, 3, 5. And circle 5 intersects with nothing. Okay, so where are the doubles counted? So 3 intersects with 2, but it's already compensated for, right? 4 intersects with 1, but it's already compensated for. So we could ignore that. 0 intersects with 2 and 4. 2 and 4. So we don't want to double count that. So let's see if we're at 11 yet. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because we eliminated the double intersections. So these are our intersecting points. Okay, so how are we going to approach this? So first, we're going to brute force it. We're not going to apply sorting initially, and then we will redo the solution with sorting in order to optimize it, right? So basically what we're going to do is have two conditions. We're going to just iterate through both from circle 0 to circle 5 and check through all the intersections and check whether it intersects. and then we'll eliminate any duplicates, and then we'll approach it that way. Because this is kind of complicated if you think about it, in my mind at least. Maybe there's a simple solution, but let's do it this way. Iterate through circles, identify intersections, store intersections. Okay. So let's get to it. So we're going to use a hash set of intersections, an empty hash set. All right, and we'll have two functions that are used for this. Is intersecting, and we'll have index 1 and index 2. These are the the center points of the circle. And we'll have another function, add store intersection, right? And we'll pass index 1 and index 2, store unique intersections. That way we won't double store it, right? So now we will have our circle. We're going to iterate through our circles for let I, or circle 1 equals 0, and while circ 1 is less than a dot length, circ 1 plus plus, right? For let circ 2 is equal to 0, circ 2 is less than a dot length, 2 plus plus. What are the conditions or edge cases where we're going to ignore it? If circ 1 is equal to circ 2, continue, right? That's one case where we want to ignore it completely, because we don't want to double count the circle, because it obviously can't intersect with itself. And then we will do this, is intersecting, and we'll pass in the first index and the second index, right? And if that's true, if they do intersect, we will store unique intersections. 1, 2. Okay, so that's our initial loop. This will find circles that intersect, right? So, what are the conditions for a circle to intersect, right, with another circle? So let's find the start of circle 1 is equal to a of idx1, and idx1 is the position, right, minus the radius. That will give us the start of the circle. We need the end. Which would be the opposite. Now we're going to get the same for circle 2, right? Okay. So, what is a condition for circle 1 not to intersect circle 2, right? So that's our initial condition, which will automatically invalidate it. So if start of circle 1 is greater than start of circle 2, and end of circle 1 is less than end of circle 2, we automatically return false. Right? Because if the circle is totally contained within circle 2, circle 1 does not intersect circle 2. Okay, so that's 1, and we're only looking at circle 1 with this example, right? So next, and at the end, if none of the conditions are met, we'll automatically return circle false for is intersecting. Okay, so now if start of circle 1 is greater than or equal to start of circle 2, and start of circle 1 is less than or equal to end of circle 2, we return true, because that means only one border is within the other outer circle, and the same applies for the end, right? So end of circle 1 is greater than or equal to start of circle 2, and end of circle 1 is less than or equal to, so greater than, less than or equal to start of circle 2. Okay, I think that gets the conditions in which our circles intersect. We'll come back to that after our check, which should tell us whether it works or not after we do a test run. Alright, so now what we're going to do is we're going to check our hash table, hash set I mean. Okay, so we check our hash set. If intersections of IDX1 type of equals to undefined, what we'll do is set it to an array, right? Because it doesn't have to have a value. There we go. The same with 2. Okay, so store unique intersections if the first one is undefined or the second one is undefined, right? We're going to set it to a value. Now we're going to check whether these intersections actually have a value. So if this dot includes, I think it includes IDX2, so if it does not include it, now next we will check the other option. Oh, includes IDX1. No, we check IDX1 includes IDX2 first. And we will check if nested within that. opposite condition. Not includes. What we'll do is we will set or add to this array dot push idx2. So this way we're containing all the mappings. So we stored our unique intersection. Now we're going to get a count. Get the count of intersecting circles. All right. So for let key n intersections, and we're going to have a variable that will store intersection count is equal to 0. So we'll get intersections of key dot length. We're going to get the length of the array, and we're going to add it to the intersection count. And then finally, we will return the intersection count. Note that this is not optimized yet. See our errors? We got a 5 and expected 11. So why? Let's go do a console.log intersections to see our array. Okay, so as you can see here, our array isn't really storing the values 1, 2, 3, 4, 5, right? So why is that? So our conditions here are probably off. That's my guess, right? Because it seems like the load is working properly. We got a 5 and we're expecting 11. Okay, so we forgot a condition here in which, as we can see, we return a false if circle 1 is contained within circle 2. But we also have to return a true if circle 2 is contained within circle 1, right? Because they're not going to have intersecting borders in that case, but they will intersect. So start of circle 2 is greater than or equal to start of circle 1, and end of circle 2 is less than or equal to end of circle 1. And in this case we will return a true. So run it. Alright, so that was our missing condition and we got an OK. Now we will take out our comments. Our console.log. Okay, and then we got an OK. So let's submit our task. And we should get 100%, except it will not be optimized, right? So we have to do a performance improvement using sorting. Okay, so now we wait. I felt that understanding this question was very confusing because you could take intersections to mean different things. But I guess this applied to the mathematical intersection sort of definition, right? So whenever you're doing a question, make sure you're solving the right correct question. Because, like for me, in a lot of cases, I have known how to solve problems, like not just in coding, but everywhere else. But I'll read the question and think that they're asking something else because I have the habit of skimming over things. So the best way to make sure you're solving the correct question is to ask clarifying questions, because the interviewer might not even be sure that they're solving of the question, right? Because they might have just gotten it from HR or someone else and be going through the motions. That's happened to me before too. So as you can see, correctness is 100%, but our performance is not doing very well. So now let's apply a performance improvement. We'll do that in part 2.